Good morning. So today we will be studying superelevation. What is superelevation? Objectives of superelevation and negative superelevation. Clear? So what is superelevation? What is superelevation? Just a brief idea I want from you. What is superelevation? The in curve areas. So centrifugal. So the superelevation is what? To counteract the centrifugal force. To what we should do to counteract the centrifugal force? We should outer rail. We should raise it more than your inner rail. Okay. So what is then centrifugal force and centripetal force? Away from the center. So when you provide superelevation, which force will act? Centripetal force. Okay, centripetal force. So then what is now objectives of superelevation? Why should we provide superelevation? For smooth curve. If you will provide smooth curve, what will happen? To smooth overturning, then more? No tilting of rails. Then, so what is the first objective? To provide to introduce the centripetal force. Okay, to introduce the centripetal force. And your next objective is to provide smooth surface for your riding. Okay, to provide smooth surface for riding. And the next one is what? To provide equal distribution of wheel loads in both the rails. Okay, to provide equal distribution of wheel loads in both the rails. So today we will be learning what is superelevation's relation with our between superelevation. How it is denoted? E. Gauge, how it is denoted? G. And radius of the what? Curve, how it is denoted? So this is your superelevation, okay? This is your slanting length. How it is denoted? S. S is your slanting edge length. These are your two rails. What is the distance between two rails? Here, suppose here is your one rail, here is one rail. Okay, what is the distance between two rail? G. Okay, which is the inner rail, which is the outer rail? This is your inner rail. This is our outer rail. So what is this here? E. Okay. So name this one A, B, C. And this inclination is your alpha. Okay. So alpha is your inclination. Now we will be doing our one load here. Just put a load. What is this load? W. What is this W stands for? W stands for what? Vehicle load. Okay, vehicle load. So what will act? What force will act? P is what? P is what? P is what? Centrifugal force. Centrifugal force. Okay, P is your centrifugal force. So now what is the equation for centrifugal force? P stands for what? What is the formula for centrifugal force? What? It is your W V square by GR. This V stands for what? Velocity in meter per second, and G is your acceleration due to gravity. What is the value? 9.81 what? Meter per second square. Okay. So now this we got it. Now we have to resolve this. Okay. Resolving the forces, force and weight along AC. What we will get? Just resolve this. What we will be getting? How to resolve this? Resolve W, resolve P. What you will be getting? Last. Where is this? W. First you resolve W. How to resolve W? How to resolve W? So here somewhere? Yes or no? So what is this one? What is this one? What is this component? Which one? What is this one? W cos alpha. This one? Then here P. What is P? Then P? Clear? Now what will be the equation we will be getting resolving the force and weight along the AC? What will be the equation you will be getting? P cos alpha equals to W sin alpha. So this is equation 1. Clear? This is equation 1. So now you say what this cos alpha stands? Cos alpha implies what? Cos alpha implies what? G by S. Sin alpha? E by? E by S. Perpendicular by hypotenuse. Okay. So we will put this, substitute these values in this equation 1. Okay. Substitute this cos alpha and sin alpha in our equation 1. Clear? Now what we will be getting? P into G by S. W into E by S. What you will be getting? Okay, this is the equation. Now, P, you know what is P? What is P? Into GS, W, E by S. What is the E we will be getting? SS also cancel. What will be getting? D square G by GR. What is this? When this equation is used? When B is in meter per second. Clear? Now we got the equation E equal to B square by G. This is small, okay? Don't miss. Okay, this is small v. So now we will be doing in kilometer per hour. What will happen? What is the formula of super elevation when your V is in kilometer per hour? When V is in kmph, kilometer per hour. This is capital V. Clear? This is your capital V. Clear? So what we will be getting? What you will be getting? E equal to B square G by GR. You have the equation. So when you are converting from meter per second to kilometer per hour, what do you have to do? What you have to do? 1000 by G by GR. Okay. This, what you will be getting? 0.278 B square, sorry, this is should be BG. Okay, so this is your B square G by GR. GR is how much? So how much you will be getting? B square G by 127 R in meters. Where R is in meter? Your R is in meter. So if your R is in centimeter, what is the formula? B square G by 1.27 R cm. Now coming to negative superelevation. Coming to your negative superelevation. Now just say, what does the negative superelevation means? Okay. Now this is your rail track. Okay. Where is your point? A, B are your points. Okay. Which is the main track? A, B, C, D. Main track. Okay. Which is your branch track? A, B, E, F. That is your branch track. Okay. That is your branch track. Now you say, what will be the superelevation? Here, in this main track, which edge will be higher, which edge will be lower? Which edge higher, which edge lower? AC higher, because this is your outer rail and this is your inner rail. Okay, this is our outer rail and this is our inner rail. So which is our outer rail? AC outer rail. Then ABD inner rail. Clear? BD is your inner rail. So which one will be the higher? Which one will be higher? Which edge will be higher? AC edge, AC will be placed higher than BD. Okay, for what? Superelevation. Okay, then coming to this branch track, what will happen in this branch track? Which one will be higher? Which is the outer rail? BF. Which is the inner rail? Yes or no? So now you say, which one should be higher? Which one? BF should be higher, will be placed higher then what? A. Okay, but this condition does not happen. But this condition does not happen because this B becomes a contradictory points. A and B becomes your contradictory points. Okay. So for this we can't place BF higher than AE. As they are contradictory, we will place AE higher than BF. Okay. AE higher than BF. Due to what? Because of what? Because of contradictory points. Because of contradictory points. So this is said as your negative superelevation. Okay. So this is said as your negative superelevation. So which one is your positive superelevation? Main track. Which has your negative superelevation? Branch track. Clear? So negative superelevation. So now what is superelevation? You learnt. What is the relationship between superelevation, gauge and radius you learnt. What is negative superelevation you learnt. Okay. Now we will be just solving one problem. Solve it. Write a question. Write this first one. On a broad gauge, 3-degree curve, on a broad gauge 3-degree curve, the equilibrium cant is provided, for a speed of 70 kilometer per hour. For a speed of 70 kilometer per hour. Okay. First bit, calculate the equilibrium cant. And next question is allowing a maximum cant efficiency. What would be the maximum permissible speed on the track? Okay, what would be the maximum permissible speed on the track? Written? Okay. So what does the equilibrium cant means? What you will be finding out in this equilibrium cant? Our superelevation. Okay. So equilibrium cant means what? What is cant? Superelevation. So equilibrium cant means find out superelevation is how much? Find how much is the superelevation. What is your superelevation? What is the superelevation? What is given? What is given? D is equal to 3 degree. Then B is equal to 70. Clear? So what is the equilibrium cant? B square G by how much? It's V. First you calculator. Why 70 square into gauge? How much for broad gauge? 1.676 by 1.27 into 1720 into 3. You can do now because R is what? 1720 by how much? 11.28 what? cm. It's clear? 11.28 cm. First bit is over. Then next bit, allowing a maximum cant deficiency. What would be the maximum permissible speed on the track? Okay. Maximum permissible speed on the track. So our second step will be to finding out theoretical can provided. What is the theoretical? Theoretical can provided equal to how much? How much? 11.28, that is your equilibrium can plus Kant deficiency. Plus Kant deficiency. So how much? What is your Kant deficiency? For broad gauge? 7.6. How much? 18.88 centimeter. 18.88 centimeter. Okay? So putting this theoretical Kant in your equation, find out what is your permissible velocity, that is your design speed. Permissible design speed is how much? Is how much? 18.88 equal to V square into G is how much? 1.676 by 1.27 R. How much is V? How much is V? Hmm? 90.5. Okay? This you got it. Now we will compare this value with our Indian Railway Board. Okay? Formula. So according to Indian Railway Board formula, what is that? Indian Railway Board. What is that? B equal to how much? 4.35 root over of R minus 67. Okay, 4.35 root over of R minus 67. So how much you will be getting? 4.35 into root over of R is how much? 1720 by how much? 3 minus 67. How much? 97.8. So which one is the minimum? So we will be taking our minimum design speed. So the allowable one is how much? Allowable speed is how much? 90.5 km/h. Next question. What would be the permissible? What would be the permissible speed on the curve? What would be the permissible speed on the curve? If on a 8 degree, what would be the permissible speed on the curve? If on a 8 degree meter gauge track, the average speed of different trains, is 50 km/h. And allowable Kant efficiency is half that of maximum Kant deficiency. Maximum Kant deficiency. Okay? So, what you will be doing here? What is the question? You have to calculate the speed on the curve for a meter gauge track, and you have to find out your maximum Okay, allowable speed by taking maximum cant deficiency. So what is the equilibrium cant? Find it out for meter gauge. What is the equilibrium cant? What is the equilibrium cant? B square G by. So how much is B square? G is how much? G is how much for meter gauge? 1 by 1.27 into R is how much? 0 into 8. How much? Everyone got? What is the value? 9.15 cm. Okay, 9.15 cm. So here what is written? You have to take the maximum cant deficiency. Okay, so we have to check what is the maximum super elevation, what is the maximum theoretical cant. So what is the maximum super elevation here? What is the maximum super elevation? 1 by 10 into 1. How much? Meter. 10 centimeter. Okay. Then theoretical cant is how much? Maximum theoretical cant equals to maximum super elevation plus maximum cant deficiency. Okay, plus cant deficiency. Now what is cant deficiency? What is maximum cant deficiency for meter gauge track? 5.1 cm. So how much is what is given in question? Cant is half of the maximum cant deficiency. So cant deficiency is how much? Half into 5.1. Okay, according to your question. What is given? Cant deficiency is half that of maximum cant deficiency. So our maximum cant deficiency is 5.1 for meter gauge. So for that half is how much? Half of 5.1? 2.55 cm. So what is the theoretical cant? What is the theoretical cant? Equal to 10 plus 2.55. 12.55 cm. Okay. By taking the super elevation, find out what is the speed. By taking the super elevation, find out what is the speed. How much? 12.55 equal to v square into how much? 1 into 8 by 1.27 into 1720. How much is v? 58.5 cm. Sorry. Okay, KMPH. Then take out your Indian Railway according to Indian Railway. Indian Railway Board, what is that? V equal to 4.35 root over of r minus 67. What is this? What is the value? What is the value? 52 point. So what is the design speed? What is the design speed? What is the design speed? Allowable design speed. Okay, so is it feasible? What is that? It is written your average speed is 50, but you are providing super elevation 52.9. Okay, so it is feasible with a question. What is the average speed? What is given in our question? This is the average one, and maximum one you are providing more than the average value. Okay, next one. Next one, do first. Find the speed for which super elevation is to be maintained if the speeds of several trains running on a main curved track are as follows. First one, 15 trains at a speed of 50 kmph. 15 trains at a speed of 50 kmph. Then 10 trains at a speed of 60 kmph. 5 trains at a speed of 70 kmph. 2 trains at a speed of 80 kmph. What is the equilibrium cant? On a 2-degree curve on a broad gauge if 15 trains, 5 trains and 2 trains are running at speeds of 50 km/h, 60 km/h, 70 km/h and 80 km/h respectively. First you have to find out the average speed, because to you average speed is not given of all the trains. What is the average speed? So weighted average speed is how much? Weighted average speed equal to N1 plus N2B2 plus by, okay, so N1 is how much? 15 into 50 plus 10 into 60 plus N3 is how much? How much? So what is super elevation? B square is how much here? (1.27) into 2. How much? 5 point. Okay, so everyone clear about superelevation, negative superelevation, okay, and your problems.